So, hello everybody, and good morning, good afternoon. Welcome to our presentation about innovative engineering, specifically in the area of safety and security. My name is Arnulf Braatz. I'm leading the team of safety and security expert at Vector Consulting Services. And yeah, I would like to start the presentation now. Okay, my presentation is structured in three main parts. One is a very short one to introduce you to the challenges of automotive system engineering. Then we'll introduce the scenario concept and how it relates to safety and security. And I will provide you a few insights in how we can optimize our safety engineering and security engineering approaches. So first of all, a small introduction of what can happen to a car, right? So that is a bit unusual situation. So a car is spotting something on the road. Oops, this is a chair. What does a chair mean? No idea. And if we come closer, we see, okay, there was a good reason for the chair. So these kinds of scenarios are called edge or corner cases. Comparable certain, but we have to keep them in mind during development to prepare our EE system for that. And but not only for that, because each kind of scenario have to be mastered by our EE system along with the higher levels of automation. Coming to the scenario term a bit more systematically, then we see we have three different kinds of scenarios. It's the unreliable scenario. We have just a fault somewhere in the EE system, something unusual happens. We bump into a person, we harm a person, that is the hazard. We try to avoid whatever is the reason, failure in the car or just traffic or weather conditions. We don't know that. That's the unsafe scenario. Then we have the unsecure scenario where we get attacked from outside and somebody steals data or manipulates data on the car. So of course, that these three scenarios are unwanted scenarios. We want to avoid these, and that is the main goal of automotive system engineering and how we can do this. Unfortunately, all the three scenarios showing up randomly and they have overlaps. The good news is we are prepared for these overlaps and for these scenarios by standards. So typically, the reliability case is handled by classic standards like SPICE or ISO 9001. The overlap between safety and reliability, that is called the functional safety. So to avoid that an internal fault can lead to an unsafe scenario, that is what the ISO 26262 is about. The rest of unsafe scenarios, whatever, is there in terms of performance limitations of sensors and actuators, unusual, unexpected weather conditions or traffic conditions leading to an unsafe scenario. That is in the new standard called SOTIF, the safety of the intended functionality. That's the ISO 21448. And for all the security stuff we have now upcoming this year, the ISO SAE 21434 has an overlap with the safety and has an overlap with the unreliable scenarios. So bringing everything together, the good news is, yeah, we have to heavily fight with the emergent system properties, safety, security, and availability, but we have established and good standards how to deal with that. Looking a bit more to the detailed level, what that means. Unwanted scenario, that's the root cause of everything we do here in safety security. So for some functional safety, that means avoiding systematic and random faults that can occur on hardware and software level and can propagate to the system level. And therefore we have the ISO 26262, which provides us methods and requirements how to deal with that. Then we have the foreseeable misuse, so people can misuse electronic functions on the car, or we have functional insufficiencies, so again, performance limitations on the vehicle and system level of the car, and that is covered by the standard ISO 21448, the SOTIF standard. And we have the attacks as a root cause, which can, of course, utilize vulnerabilities on hardware and software level, and even that propagates then to system level, and that is on the, or it's covered by the ISO SAE 21434. The good news behind this, yeah, we have three standards. They have somehow a complementary relationship to each other. But the very good news is that we have one engineering approach behind it. So the risk-based approach, which is set up to avoid unreasonable risks in the area of requirements, design, and verification. That is typically called the three-pillar approach. And on the horizontal layers, we have the levels of refinement from the vehicle level down to the implementation. That's the process side, that's the development side, and below that, of course, on the implementation side, to make a function safe and secure, we have also requirements how to implement that. And these both things together form the WIS-based approach, which is shared by all the three standards. Okay, picking that up and showing you what can be optimized there. That's the goal of the next section. So yeah, we have a function. We want to make that safe and secure. On the implementation side, on the process side, we have many options to do that. So we learned already we have to regard 3 different standards, and these 3 standards are a bit different. So you see on the left side the ISO 26262, which appears comparable mature, very good in process codes, very good on guidance and methods, a bit limited on the technical solution side. But it's a bit, it's worse for the other both standards. So there we have, of course, good guidance about process codes for SOTIF and security, but very limited guidance on methods. Just a few methods are described in these standards. Very much the standards leave it open how you do something, how you reach a goal. And there are nearly no hints for technical solution, no requirements, no guidance on that. Okay, that is like it is, current situation, the standards, that is room for interpretation, but there's also room for improvement. So we want to show you here in this presentation 3 examples how you can utilize these scopes of interpretation for introducing some improvements on the methods side. So we have three different kinds of proposals. One is down to the technical solution side, what we can do there to make a function safe and secure on the implementation side. And we have 2 further improvement proposals, one for higher level design, for analyzing the design for SOTIF and security. And we have also for the verification side, one proposal how to improve testing for cybersecurity and the SOTIF part, how to improve there. Of course, that's not everything. There's much more room for improvements, but in this time frame, we cannot show you everything, of course. Yeah. The lack of standards is a chance to introduce something new. That's the message here. So starting with the first improvement means making a safe and secure function technically safe and secure. So one example is a typical ASIL-D level 2 KL4 function. So all 3 standards are covered. So we add this function by well-known safety mechanisms like a range check, like a plausibility check. We put in program flow monitoring, we put in memory protection and other safety mechanisms that is covering functional safety in SOTIF. And then we put in some security controls and to make the whole function safe and secure. That is more the classic side of safe and secure functions, but more and more with higher levels of automation, we move into the non-embedded part where we have, for instance, automation level 4. Still ASIL-D and KL4, so we need some redundancy there. So that means 2 of those classic safe and secure functions, as we can see them on the left side, to increase availability. And we need, of course, even in addition to that, 2 high performance functions to do all the sensor fusion and high computational stuff. And even those need a bit security and safety, but not so much. The most part of the safety are on the classic function side, but fail operational is even needed here. So that is just, again, the second interpretation of another kind of safe and secure function. So the message here is not to recommend one or the other solution. The message is that we need harmonization here on both sides, on the classic side, on the upcoming higher level performance side. We need harmonized technical solution, not to invent the wheel again and again. Maybe on the standard side, maybe on a kind of technical solution as we know it from AUTOSAR. And we need specifically for the right side, for the higher level automation functions, more off-the-shelf availability of safety and security mechanisms. That means software and hardware. Second field for improvement is the safety and security analysis. So on the left side, you see the classic approach by functional safety and SOTIF, how we do that on the highest level. We apply the HARA, the hazard analysis and risk assessment. We start with vehicle function and we consider that function in different operational situations. That leads to potential misbehaviors, that leads to malfunctions for functional safety, that leads for both standards to hazards, which should be avoided, of course. For functional safety, we apply safety codes with an ASIL. For the SOTIF, we just apply measures to minimize the risk coming out of this analysis. But we do not follow the operational situation down in the solution levels coming below that. We just refine the safety codes and the measures. So, and another approach is to apply system theoretic process analysis, abbreviated by STPA. That is a method which works in the system architecture, so with a real function and actuators and sensors which are set into relationship with the vehicle and its different driving situations. So it's not just a high-level picture, it's a real system architecture. And it's two steps we need for that. We take the headers, we look for some outputs of the functions, which is called controls, if they are hazardous or not, so if they can cause a hazard or not. If we have found these controls in a list, then we relate these controls to potential root causes. So we have dedicated spots in the architecture where an causal factor, a fault or failure can occur, or a flaw could occur. So that is considered systematically, and then we get finally all the root causes for the hazardous controls and can minimize then the risk, as we have, if we would do that in the area of applying FMEA or FTA. So that means that is a great method. It's has been applied in other industries, not so much in automotive so far, but it's a great technique to improve safety analysis and could replace FMEA, FTA, at least on the system level. And it's also good enough for security. So in step 2, you could also introduce threat models like STRIDE to find out what are potential root causes for hazardous controls from the security point of view. So both standards can be covered with the same method. So last one of our improvements is the in the testing area. There we have a stack of testing methods. So it starts on the very low level with somehow static code analysis, but the fundament of testing is always requirements-based testing to find out if my solution can be verified against the requirement. That is true for all the standards. They have all requirements-based testing in. That's the first level. In the middle, we have specific test methods specific to security and safety. So it starts with the safety-specific stuff, fault injection, error guessing that is required by function safety and SOTIF. Then we have the integration-related testings to correctly integrate components, technical components, which is only covered by function safety and security because these both standards are dealing with the integration of technical components. And then we have a specific one for security, which is quite new. And this introduces two test methods, which are meanwhile also known as the fast testing and the white box pen testing to identify so-called vulnerabilities in our solutions. So that's the middle part, so the specific part for safety and security. And on the top, we have the vehicle-related testing methods, and there we find not so much support in terms of guidance in the named standards. So a bit we find in the SOTIF and function safety about long-term testing and test drives, but that is not real testing methods we would need on these levels for safety and security. So to prove, for instance, if hazards which occur or could occur on the road are statistically below an expected level, so that cannot be done by just driving around with a car. So for that, we have specific methods. One is mentioned in the SOTIF standard, that's the loop testing with support of simulation of selected scenarios, including, of course, the edge cases. And that is a very good one to cover millions of test drive kilometers, which cannot be done with real cars because just the amount of time is not there. So we have to find a way to constantly drive on roads without using a real car, and that is done by virtual simulated environments which simulate the roads, environment, traffic, the ego car and the driver, and including the sensor and all the stuff we need for implementing a safe function. And you put that into a loop with the ECU. And so you can verify and validate your ECU in the context of real driving scenarios without being out in the road. That is one thing we think need to be added and better explained and better better applied in the projects to support ECU development in the area of safety. And the second one is in the area of security. That's the black box pen testing on the vehicle level. It's not so much about the black box, it's more about to attack cars with a full network of ECUs and items to find out if multi-item vulnerabilities in the car are sufficiently covered or not, which cannot be done if you just look at single items. So this is one technique. It's mentioned in the security standard, but you need more method guidance on that. Yeah, that means finally, at the bottom line, we need much more testing efforts on the vehicle level, including virtual test driving, to improve our safety and security. So summary from what I've shown so far, yep, it seems that we need much more expertise concerning methods, tools to make appropriate decisions in the area of safety and security. We need even new methods to master the new challenges. We cannot just improving those we know already since decades. And of course, also the interplay, the work mode between suppliers and OEM will change, specifically with the test method I have shown on the slide before. That needs some new interactions between suppliers and OEM to do these, to apply these testing methods. Yeah, you need a strong partner for that, I think, and I hope Vector Consulting Services could be such a partner, right? And that is an overview about our portfolio and typical consulting projects, even safety and security you find in there. And we hope we can support you there in your projects. Okay, thank you for listening to this presentation about safety and security. So stay tuned. I'm looking forward to your questions and hopefully I can answer them. So stay tuned and give us a few seconds to switch to there.